In this chemical equation, we have aluminum sulfide reacting with sodium bromide and producing aluminum bromide along with sodium sulfide. Let's start by determining how many atoms we have for each of our products. We have 2 for aluminum, we have 3 for sulfur, 1 for sodium, 1 for bromine. On the product side, we have 1 for aluminum, we have 1 for sulfur, we have 2 for sodium, 3 for bromine. Next, we need to identify the loner, and that is the one that is not part of a compound. In this chemical equation, we do not have that, so we're going to skip that step. The next step is to identify the 1:1 ratio, and that is the element that appears one time in the reactant side and one time in the product side, and it does not matter if the subscripts are different, and they can be part of a compound. So aluminum, it appears one time in the reactant side and one time in the product side. The same thing with sulfur, the same thing with sodium, and the same thing with bromine. Now we need to start with the largest 1:1 ratio, and this is the element that has the largest subscript. So notice that there are 2 elements that have a subscript of 3. So at this point, it's your choice of which one you want to start with. I'm going to start with bromine. So notice that I have 3 atoms of bromine in the product side and 1 in the reactant side. So I'm going to lock this in with a 1. 1 times 3 gives me 3. So therefore, I want to have 3 over here. I'm going to write a 3 in here. So I now have 3 bromides. So now the bromides are balanced. However, there is a problem with that already. Notice that you have 1 aluminum here in the product side. And over here in the reactant side, you have a 2. I wrote a 1, meaning that I have already locked this compound, meaning that I'm not going to mess with it unless it's one of those chemical equations that consists of using decimal coefficients. However, this is not one of those. So I have to rethink my process. That cannot be right because it's going to cause conflicts with the aluminum. And I just wrote it so that way you could see how we come up with this coefficient numbers. So instead of writing a 1, I'm going to write a 2. If possible, in some of the chemical equations, try to keep the coefficients low. Now, it doesn't happen in every case, but try if possible. So 2 times 3 gives me a total of 6. And now I need 6 atoms of bromine over here. So I'm going to write a 6. Now our bromides are balanced. And I have 6 sodiums now. So I'm going to change that to a 6. So if I have 6 in the reactant side, I need to have 6 in the product side. So 3 times 2 gives me a total of 6. So the sodiums are balanced. And now that I added this coefficient of 3, my sulfurs have changed to 3. So do I have 3? Of course, but I need to lock this compound with a 1. 1 times 3 gives me 3. So that's okay. And then look at this. 1 times 2 gives me 2. So I better have 2 aluminums in the product side. Do I have them? Of course. I just need to change this. And at this point, everything is balanced.